All right, so this is still assignment 3-4. I am experimenting again. So this is with a different product to be able to video my support and lessons and stuff. You get to see my face. I don't know if that's an advantage or not instead of just the hands. In fact, I know it's not an advantage, but I'm going to try it anyways and just go for it. So last time I did video, it was with Zoom, and I tried to do it in a very weird kind of way, and I think my voice and my mouth weren't like quite together. I think on this one, I think my mouth and my voice are together. So we'll see. This might be the new way, or it may not be. This might be the only one. But the last one I didn't do, so I grab this here, is question number 5. So let's start there together. So we have x cubed, subtract x times y equals 3. What I want to do is take the derivative of this and find the derivative at a point. So let's do that. And we're going to do it what we say with respect to x. Respect the x. So all that means is that when you take the derivative and it has a y in it, it needs the hook y prime when you go through it. Here, get this arrow out of the way. All right, here we go. So the derivative of x cubed is 3x squared. All good. No y in there. Subtract. Now, the challenge becomes xy is actually a product. And it's easy to forget. But I can tell you again and again and again, xy is a product, which means to take the derivative, I need the product rule. What is the product rule? It's the first times the derivative of the second. Well, the derivative of y is 1, but it needs a y prime because you took the derivative with a y in it. Plus the second times the derivative of the first. The derivative of x is -1. No hook needed here because you just took the derivative with x in it. And then the derivative of any constant, 3 included, is 0. Keep going. I want to get this part by itself. So anything that's not a part of y prime, it's going to go on the other side. So negative x times 1 times y prime is negative x y prime. So that means we're going to subtract 3x squared. Y times -1 is negative y. So I'm going to add y, so it's on the other side. And then the last step to get y prime by itself is to divide. Now, it's okay again, when you do it implicitly, x's and y's will be a part of the answer. Then the next part said, okay, find the derivative of what? 1 -2. So one way to show that is to draw a line and then write down what you're substituting in. So that means where there's an x will be 1. The y is going to be -2. And then simplify this. So this is -3 and -2. So that's -5. And then when you divide it through, the value of the derivative there is 5. All right, number 6. So for number 6, we have y cubed plus y squared plus x squared equals 0. And we want to evaluate the derivative at a point to -2. But first we need to take the derivative. So the derivative of y cubed is 3y squared, but it needs the hook y prime. Y squared is 2y, but it needs the hook y prime. So whenever you're taking the derivative and there's a y in there, it needs that hook. The last one has no y, so it's just 2x, and that's equal to 0. Next, what has a y prime? We're going to keep that on the left side. But this part, plus 2x, we're going to subtract it to the other side. Now, in order to get y prime by itself, at this step, because there's 2 terms, or there could be more than 2, that have y prime in it, we have to factor out the y prime from each term. So factor out the y prime, that's 3y squared. Factor out a y prime, that's 2y. And that's equal to 2x. So then the next step to get y prime by itself is simply to divide. Now, once you have the derivative, just double checking on the answer key that I did it okay. Looking in the right spot. There it is. Good. Always good to double check that I did it right. The point that you're going to substitute in is 2 and negative 2. So what does that mean? Where there's an x, plug in 2. Where there's a y, plug in negative 2. And just be careful how you evaluate it. That's all. Please excuse my dear Aunt Sally. Make sure you know your signs and a whole bit. So the numerator is negative 4. This is 4 times 3, which is 12. And 12 take away 4 is 8. So I can see this simplifies to negative a half. Yay, matches the answer key. Number 7. In number 7, let's write down the implicit. And again, the word implicit means that it's not in the form y equals. And it might be challenging to write it in the form y equals. If it was simple to write the equation as y equals, you would. And then you would take the derivative to be simpler. We're not trying to be difficult for the sake of being difficult. What happens in this situation is that you have x's and y's jumbled together. Is there a way to take the derivative in that situation? That's what we're practicing. So the derivative of x cubed using the power rule is 3x squared. The derivative of y is 1, but it needs a y prime as a hook. So x's don't need anything, but the y's do. X, y beside each other. That's a product. Tell yourself 2x times y. So the product rule is the first times the derivative of the second, which is 1, but we need the hook y prime, plus the second times the derivative of the first. Now, the challenge is we need to bring together the y primes, and those that don't have a y prime, they need to be on the opposite side of the equation. So, because I'm going to write y prime equals, I'm going to keep the y primes on the left side. So 1 times y prime is y prime. I'm going to keep it on the left. And then this part here that has a y prime, 2x times 1 is positive 2x. So I'm going to go subtract 2x y prime to bring it to the left side. Here, 3x squared, I'm going to subtract 3x squared, and then the 2y will stay on the right side. My goal is to get y prime by itself, so it says y prime equals. So I'm going to factor out a y prime. So factor a y prime out of each term. Why do we do that? So we can divide and get y prime by itself. So what does y prime equal? Is this, and again, I don't want you to be uncomfortable because it's x and y together in the answer. It's okay that x and y are together in it. So our next step is to evaluate at the point 1, 1. I'm getting used to looking at myself in the video. Be like my kids when there's a mirror. So 1, 1. Can't pass a mirror without looking at it for sure. Certain age. So wherever there's an x and y will be 1. So I'll go the long way here. Then I'll simplify it. So I put, I always use parentheses when substituting in so I don't make a mistake with signs. So this is negative 3 plus 2. I think that's negative 1. 1 take away 2. I think that's negative 1. So I get the answer positive 1. I'm going to check the answer key to make sure number 7. Perfect. A win. Number 8. Now, number 8 and 9 are together. They're the same equation. So, even though if they don't look like it. So, x squared plus y squared equals 25. Use implicit to find the derivative and then substitute in. So, to take the derivative, it's 2x and 2y, but it needs a y prime is equal to 0. To get y prime by itself, you're going to subtract 2x, and then you're going to divide everything by 2y. So if I fully simplify this, obviously the 2y's divide out, the 2's divide out, and I got negative x over y. Then I'm going to substitute in, what am I going to say? 3 negative 4. So that answer is positive 3/4. Yay, I did it right. Number 9 is actually the same equation, but in number 9 they took this. This is an equation of a circle. They took the equation of the circle and they solved for y. So that means they subtracted x squared and square root. Now when you do that as a function, the answer could be positive or negative. That would be the top half and the bottom half of the circle. So for this one, when they wrote it, this is the bottom half of the circle because it has the negative in front. So it's the bottom semicircle. And then take the derivative of this. Well, if I'm going to do that, I need to write it calculus friendly to begin with. So to the exponent 1/2. Then take the derivative of that. So 1/2 times -1 is -1/2. And then 25 subtract x squared. Subtract 1 to 1/2. So 1 take away 2 is negative. And then there's a hook inside. So what's the derivative of the base? That's -2x. So I'm going to clean that up first. So the part that's in front, -1/2, can be multiplied by what's at the end. So -1/2 times -2, they divide, or half of 2, a negative times a negative, that's just 1. So it's 1x, and then it's 25 subtract x squared to the -1/2. Now in this situation, I only need the x coordinate. So the x coordinate there is +3. That's all I need. So we have +3. 25 subtract 3 squared to the -1/2. So all I need is the x coordinate there. So now I'm going to simplify it. 25 take away 3 squared. So 25 take away 9 is 16. You might hear my kids in the background. It's okay. They might come in and say hi, or they might interrupt the video, and I'm just going for it. So if they do come in and someone got hurt or someone cries or wants attention, then that is life 101, I think. So anyways, the exponent 1/2 means square root. So the square root of 16 is 4, but the negative exponent means it goes in the denominator. And then what do you notice about those two answers? They're exactly the same. So one is done implicitly, and the other one is done explicitly. So explicit means it's in the form y equals. And you get the same answer both ways. Number 10. Number 10 is a good one. So number 10 says use it explicit differentiation. No, given x squared plus xy equals 4. Find the second derivative. So our goal is to find the second derivative. But in order to find the second derivative, you have to find the first derivative. So let's do that first. So the first derivative is 2x. Then the product rule. First times the derivative of the second plus the second times the derivative of the first, and then the derivative of 4 is 0. Notice the derivative of y is 1. The more we do this, we'll just get and write down y prime, because y prime times 1 is y prime. All right. What's our next goal? Oh, to get this part isolated. So how do I do that? So x times y prime. I'm going to subtract 2x and subtract y. Then to get y prime by itself, I'm going to divide by x. Now, I'm going to simplify this to make my life a little bit easier. So when I divide by x, x divided by x gives me -2. And then I have minus y over x. So why did I do that? Well, that just makes, so now when I take the second derivative, the derivative of -2 is 0. So I don't have to even worry about that part. But this part I do have to worry about. So this is going to involve the quotient rule, because it's y divided by x and not the product rule. All right, what is the quotient rule? It's the bottom times the derivative. Now I'm going to say the top is -y. So the derivative of the top would be -1, but it needs a y prime. Subtract the top, which is -y, times the derivative of the bottom, which is 1, and then the bottom squared. Now we're going to simplify this. So x times -1 is -x, but I'm not going to have a y prime in my answer. In fact, the question said only in terms of x and y. So no y primes. So what could I put in for y prime instead? Well, I know what y prime equals up here, but instead of using this one, I'm going to use this one up here so I can simplify it. So why am I using the one above for this case, because with algebra it's going to be easier having that common denominator. So negative 2x minus y over x, that just got plugged in here for y prime. Then continue, a negative times a negative, y times 1, that's just y, and that's over x squared. So again, why did I pick the version, the form of the one before? Because I recognize that when you go x divided by x, they're going to divide out, and then a negative times a negative is 2x, a negative times a negative is plus y, plus another y over x squared. So put this all together, just making sure I did it correctly. I got to turn the page. So for number, I got to turn the page for my answer key. Good. All right. I like it when it comes together. So 2x, that's the A team right there. Like our news team, but the 80s show. 2y. Perfect. It worked. Yeah. If you ever watch the A team from the 80s, that's what he says. I love it when a plan comes together, right? Right there. Done. All right. Number 11. Find an equation of a line tangent. Well, whenever I hear that word, I go x equals y equals slope. Those are the three things I need for a tangent line. And in this situation, it tells you the x is negative 12. The y coordinate is 5. Oh, and the slope, I don't know. But to find the slope, I need to take the derivative. So I'm going to do that. So to take the derivative of x squared plus y squared. So that's 2x plus 2y equals 0. That's the derivative. Oh, this needs a y prime. If you don't do that, then you won't have a y prime equals to anything. So I have 2y times y prime. Subtract 2x. Our goal is to get y prime by itself. Divide. Then simplify if you want. There it is. So there's the derivative for that. And you know it's a circle. So then what do? Is I substitute in. So for the x, it's going to be negative 12, and for the y, it's going to be 5. So that's 12 over 5 once you simplify it. So now I take this information and go, okay, what's the equation of the tangent line? It's y equals, the slope is 12 over 5. The x coordinate, change the sign. The y, keep the sign. And you did it. Let me just make sure I did it right. Perfect. Done. 12. Number 12 says, find the points at which the graph x squared plus 2y squared, subtract 4y, subtract 6 equals 0, has horizontal tangent. Now, whenever you see the word tangent, that's another word for derivative, so I know I need to take the derivative. The word horizontal means the slope is 0. So the slope of a horizontal line is 0. Horizontal tangent line means the same thing. So in other words, I'm going to take the derivative. Let's do that first. Make sure that whenever you have a y involved, you need a y prime. Know the derivative of negative 6 is 0. That's why it's there. Next, I'm going to get y prime by itself. So how do I do that again? Well, first I'm going to subtract 2x. Then I'm going to factor out a y prime so I can divide and get y prime by itself. So I'm going to divide by 4y, take away 4. Perfect. Then what do I do with this answer? Is I make that equal to 0. So you just found the equation for every slope of that curve. So this will give me the slope. We want when is the slope equal to 0. So make it equal to 0. Now for this one, for this to be equal to 0, I'm just looking on the answer key real quick. All you need is the numerator. So if the numerator is 0, then 0 divided by anything, the answer is 0. So in other words, if you take the numerator and solve it, for what x value? So it says find the points though. So the x coordinate is 0, because if you plug in 0, your slope is 0. But then it says go back and find the y coordinate. and then tell me the point. So I got to go back, way back to the beginning, and plug in 0 for x and solve for y. So wherever there's a x, I plug in 0, and now I'm going to solve for y. So now it's going to take some algebra to do this. So I notice right away I can divide by 2 to try to make it a little bit easier. And I know I can factor. So what are the two numbers that factor this? So it'll be -3 and +1 that multiply to -3 and add to -2. The first factor gives you the answer 3. The second factor gives you the answer -1. So, oh, I can get this off there. So the question still is, at what points are there horizontal tangents? And so for the point, the x is 0 and the y is 3, and the x is 0 and the y is -1. So at what 2 points do we have horizontal tangents? And it's at 0, 3 and 0, -1. So being a good reader, are they asking for the x coordinate, or are they asking for the point in terms of what you're looking for? All right, number 13, I don't have to redo everything. That was a lot of work. For number 13, you have the same exact equation. We already have the derivative, so I'm going to start there. So we already did the work, and we said the first derivative is -2x divided by 4y, take away 4. But this time, it's asking not for the horizontal tangent, but for the vertical tangent. So the word tangent, there it is. That word means slope. So vertical slope. What is the value of a vertical slope? And you go, a vertical slope. So a vertical line, we need to remember, the slope is undefined. So, in other words, when I come here, what value for y would make this undefined? So how do you know when this is undefined? It's when the denominator is equal to 0. So if the denominator was 0, then it would be undefined, and that would describe a vertical tangent. So add 4, divide. So now we're going the other direction. So we know the y-coordinate. When the y-coordinate is 1, we have a vertical tangent. That means the denominator is 0. That means the slope is undefined. Next, I need to find the point. So I need to find the x-coordinate that goes with it. So I got to go way back to the beginning again and substitute in and find the x-coordinate that goes with it. So I need to plug in 1 for y. So I have x squared plus 2 times 1 squared. Subtract 4 times 1. Subtract 6. Now I'm going to solve for x. So this is 2 take away 4 take away 6. That's -8. So when I solve this, I'm not going to worry about simplifying the square root. So I don't think that's necessary. But when you square root both sides, when you solve the quadratic, recognize the answer could be positive or negative. And it's root 8. And yes, you could write it as 2 root 2. So there are 2 points. So the first point is positive root 8 and positive 1. And the second one is negative root 8 and positive 1. So at these points, we have vertical tangents, which means the slope is undefined. So here, what makes it undefined is when y is equal to 1. Up here, we're told about horizontal tangents. A horizontal tangent means it's not undefined, but it's equal to 0. That's the numerator equal to 0, and you found it. Then we went way back to the beginning to find its pair. So if we know the x-coordinate, we have to go way back to the equation to substitute in and then solve for y to find its y partner. And that's it. So vertical, horizontal, and vertical, and what they mean. Understanding the word derivative, the word tangent means slope. So horizontal means the slope is 0. Vertical means you have a slope that is undefined, which means the denominator is 0. Number 14. Number 14 says the volume of a sphere is 4/3 pi r cubed. It says find the rate of change of the volume with respect to the radius. So in other words, find dv by dr when the radius is 4. So to do this, we're going to take the derivative. So the derivative here, we actually only have one variable. That's r. So if you look at it, it's the power rule. Pi is also just a number. So the only variable is r. So we're going to take the power and multiply. So what's 3 times 4/3? That's right, the 3's divide out and leave you with 4. Subtract 1 to the exponent, and there is the derivative of that sphere. So to find the slope of any tangent line, to find the derivative, we have a formula for the derivative now. And then it said, all right, use that. That's dv by dr. And then find it when r equals 4. So when the radius is 4, at what rate is the volume changing with respect to the radius? So we're going to substitute 4 in and keep pi in our answer. So we got 4 times 4 times 4. That's 64 pi. Do you have any units? Nope. So we could call this units cubed as a rate in terms of the radius. I want to see how the answer, they wrote it down. 14. They just wrote down 64 pi, so I'll just let it go. So usually when we have a rate, if we have units, we need to compare 2 units for a rate, but we're good. All right, now our questions involving the graph in front of you. Can you find limits off a graph? So I'll put it here, and you can write down the question, just answer it. I'm just going to answer it right in here, but you'll need to answer it, like write down the question and answer it on your answer sheet. What's the limit as x approaches 1? So do you see where 1 is? I see it. From the left and from the right, is it approaching the same y value? Yes. Doesn't matter that there's a hole when you get there. No. So the y coordinate is approaching the same on both sides. And when you get there, it's undefined, and that's okay. This is called a removable discontinuity, and the limit exists for removable continuity. Make sure I did it right. Yes, it is 16. What's the limit as x approaches -3? So when I look at, find where -3 is, that's the vertical asymptote. What's happening on the left and on the right? Are they doing the same thing? Yes. Where are they both going? What y value are they going to? So the answer is both the left and right are going to infinity. So that's a great answer. You could also say that the answer does not exist because it's impossible to approach infinity. So both are correct. 17. Find the limit as x approaches -infinity of f at x. So in this situation, that's a way of saying -infinity. Where's the left end behavior? What y coordinate is this getting closer and closer and closer to? So by looking at the graph and how it's flattening, I can see that it's getting closer and closer to 0 on the left in terms of the y value. 18. Find the limit as x approaches 2 of f at x. So here's +2 from the left and from the right. Are they approaching the same y coordinate? In fact, there's a jump at 2. So there's only one correct answer here. This is the Mean Girl answer. The limit does not exist. Goes back to the movie Mean Girls at the end, right? Lindsay Lohan. Go back to the very first lesson for summer, right? I gave you a little clip of that movie. Find the limit as x approaches 2 from the right. So that plus sign means from the right, what's the y value? So from the right, the y value is +1. Number 20. List the x values of all discontinuities. So for number 20, where are all the discontinuities? So as I look here, the first one is here, and you're going to have to write it down when x equals -3. The next one is here when x equals 1. And the next and last one is when x equals 2. Here it's continuous, but it's a vertical tangent. That's what's showing. So where is it not continuous? -3, +1, and +2. You can write that down. Which of these are removable? So the definition of a removable discontinuity is that the limit exists there. Now, in this situation, infinity, you have to think of it as it does not exist. So the only removable one is right here. So that is a removable one because the limit exists there. So in this case, infinity or -infinity does not count. And here we have a jump where it doesn't exist. So only one. It says where are they removable? Oh, 22. Where are the x values where they're not differentiable? So you can't differentiate where there is a discontinuity. So at -3, at +1, and at +2. So the limit exists, but the derivative does not, if there is not continuous. So something that where there's a discontinuity, the derivative does not exist there. So at -3, at -1 or +1, and at +2. Where else would the derivative not exist? And if you look right here, it's at that cusp. So even though it's continuous, the derivative on the left does not match the one on the right. And so if you see a corner or a cusp, that's also a place where it doesn't exist. So that's at -1. Let's see if I got them all. Oh, another one. See the vertical tangent here? So the derivative, the slope, is undefined, which means that the derivative is undefined. So at +3, so notice a vertical slope, undefined, the derivative doesn't exist. At a corner or cusp, does not exist. And where it is not continuous, it doesn't exist. All right, use a calculator to solve this inequality. Let's do that. I'll show you with this one. So I'm going to press menu. I'm going to go to algebra. I'm going to go to solve. I think I can just type it in. It'll give me the answer. Let's see. So 2x squared minus, or subtract 7x plus 4. Now, for those arrow signs, you go control. So press the control button and equals. And then what pops up, you want to make sure the arrow matches, which is less than or equal to. Press enter, and then it is what? 0. And then go comma x. I think this is going to work, or it may not work. I think it'll work. So then go control enter, and you can see that. And then when you write the answer down, you have to write the answer down to 3 decimal places. So that's why we needed a calculator. So that's 0.719. And 2.78. Now you can truncate or not. I just get used to truncating. Just go with the 3 numbers you see and don't worry about rounding. 0.2780. Done. So isn't it nice to have that? Otherwise you'd have to graph that and recognize where that graph is below 0. But this way we didn't have to do it. The calculator did the good work for us. 24. An object's velocity is given. Find the object's speed each time the acceleration is 0. So to find the acceleration, we're going to take the derivative of what we see. So 3 times 2 is 6t squared. 2 times -9, 18t. 12t is just 12. And -5 is 0. We're going to make that equal to 0. So it says when the acceleration is 0. Solve it. We're going to divide everything by 6. So -18 divided by 6, that's -3. 12 divided by 6, that's 2. We're going to factor it. So the two numbers that multiply to 2 and add to -3 and then solve it. So in this situation, to solve it, the first factor gives you +2 and the second one gives you +1. So find the speed each time. Just know that it's the absolute value that we're looking for. So when t equals 2 and 1. So the absolute value. So we'll put 2 in first. So speed is the absolute value, always written as a positive number. And it's meters per second is the speed. So if you substitute in, that would give you the answer +1 if you did the absolute value. You can use your calculator. I'm just reading off the answer key. So it's 1 meter per second, that's the speed. And then if you did the same thing and you plugged in 1, this would be a lot easier. So when you plug in 1, 2 take away 9 plus 12 take away 5. That, I think it's just 0. It is 0. So that's 0. So what does that mean? 0 velocity means the object was resting and the acceleration was also 0. So both were 0. And then here at time 2, the speed was 1 meter per second. All right, last one, number 25. I have room to do it right here, so I'm just going to do it right here on this sheet. Why not? So, and I want you to write it on your answer key and then take a picture of it, upload it, and all that good stuff. So, here what I noticed first, before, I could do the quotient rule, but what I notice is that we have a monomial. So what I can do is I can simplify it first. So x squared divided by x squared is 1. And then x divided by x squared leaves with 1x in the denominator. And I can write the 1x in the denominator to the negative 1. So now when I take the derivative, after I do the simple algebra hopefully, the derivative of 1 is 0. Negative times a negative is positive 2. Subtract 1 from the exponent. Oh, what just happened here? Yeah, subtract 1, sorry. Negative 1, I thought it was going to be a 0. Subtract 1 from the exponent, and it's 2x to the negative 2. And you could also write that answer as simply as 2 over x squared. That's it. You did your work. I am proud of you. You can actually now see me that I'm proud of you, that you're doing your work. Keep it up, and until next time.